Hello YouTube. This video is about lowering the front of the motor to be in compliance with NHRA's rule with the center line of the crankshaft being no more than 24 inches from the ground. In the last video we put new tires on the front which lowered the whole front by 3/4 of an inch. We lowered the back transmission mount by 3/4 of an inch, and what's left is to lower the front of the motor by 3/4 of an inch so that we get our drive line angles back. There are several ways we can go about lowering the front of the motor, but the first thing I want to do is hang this motor off the engine hoist, take the engine mounts off, and see what our drive line angles are like. I'm sorry, we have a number of explanation and measurements to take before we can go further. We clamped a piece of 3/4 inch tubing to the bottom of the frame so that we could take accurate measurements between the frame and the center line of the motor. What I'm going to do is use this peak of the bolt to take accurate measurements from, because what we have to do is lower the motor 3/4 of an inch. This measurement before we started was 6 7/16. To lower 3/4 of an inch, we got to go to 5 11/16. And that's currently where we're sitting at, 5 11/16. A while back we did a video on driveline angles on this chassis, and we had the engine set at 5 degrees and the driveline was at 5.5, which gave us an excellent driveline angle of 0.5 degrees. Because the floor in the garage is not level and the motor is not sitting in the chassis, we have 1.5 degrees on the chassis, and if we take that and put it on the motor, we have 6.6 degrees on the motor. If we take 1.5 away from 6.6, we end up with 5.1 degrees. So we have 1/10 of a degree that's not explained. This is what the current motor mount bracket looks like when it's been lowered 3/4 of an inch. It almost appears that we could drill a new hole in the brackets on the transmission and lower the motor 3/4 of an inch. But we're not going to do that. What we are going to do is pick the motor out of the frame, remove the mount, and see what we can do to the mount. We have removed the engine mount bracket from the engine. To compare it with a bracket that I bought off the internet that looked like it was smaller, but it turns out it's not. It's the same. And in fact, I'm not impressed with the build quality because all they have is a little tack on that top rod. So we're not going to use this motor mount. It appears what we're going to have to do is cut these brackets off and make new brackets out of the brackets that were sent with the motor mount. I think the way to go is to create an aluminum template of this and fit it to the engine and the frame. The first thing we have to do is cut these brackets off. So here we go, point of no return. One down, 2 more to go. We have the old brackets cut off and the surface is ground down flat. And what I envision is the brackets hanging off the outside of the frame and encapsulating the frame in the bracket. Rather than work with this heavy gauge metal, and if I was to make a mistake I'd be done because I've only got 4 of them, we're going to make patterns out of this aluminum and then trace them out on these and then cut these. We have the transmission bolted to the transmission mount, and that positions the motor in the correct position forward and back in the frame. We have the engine hanging from a hoist. The engine height is 5 11/16, 2 3/16 from the outer edge of the frame. And this side is also at 2 3/16. So the motor is hanging exactly where we want it when we put the brackets in. Now we can make the templates to fit where the motor is sitting. We have one of the purchase brackets clamped to the aluminum, and we're going to scribe it. Then we'll take a center punch, which is nothing more than a rod with a point on the end of it, the rod being the size of the hole, and we'll put it in the hole and mark the center of the hole, and now we'll go cut it out. What I've done is cut a 3¼ inch wide strip of aluminum, which fits our template, and I suspect that we're going to make some mistakes and have to cut more than one. We'll drill an 1/8 inch pilot hole in our punch mark. This is 3/8 of an inch, and this is a 1/2 inch. And now what we have is a copy of the original that we can play with without ruining the original. We have our pattern cut out. How do we make it match the frame? The only thing common between the bracket that was sent to us, the pattern that we made, and the motor mount is the hole. So we'll take measurements from the hole and transfer them to the pattern. The first measurement we'll take is the distance between the hole and the frame. This is why we're making a test piece first. The best measurement I can come up with from the inside of that hole to the frame is 0.600. So we'll mark off that dimension on our sample. For the next guesstimate measurement, we'll put the bolt in a hole and sight across the bottom of the bolt and the frame, and we have 0.318. And I'm making all these measurements tight so that I can grind them off. The next measurement we'll take is on the frame, the width of the frame. And the measurement I get for that is 2.570. I don't know if you can see it, but we have marked out here a notch to cut out so that this will fit into the frame. So I'm going to go cut it out. Here's our first test fit. And the bolt goes in the hole, but the notch is not high enough, so it won't let the pattern sit down onto the frame. So we got to grind a little bit out of the notch. I've ground the pattern down a little bit. We were off by 3/16 of an inch on our height. If we slide the motor mount bolt in and into the bracket, it fits nicely, sits down onto the frame. I in fact have made the front mount. So if we slide that in and slide the rear mount in, that's kind of what it'll look like. We want to check to make sure the top of our brackets are parallel with the frame. So if we measure the frame, we have 0.4 degrees. If we measure the top of the bracket, we have 0.5 degrees. And if we measure the top of our other bracket, we also have 0.5 degrees. I think that's close enough. The next measurement we want to make sure of is that we haven't moved the motor over sideways. If we measure here, we have 2 3/16, which is what we started out with. So now we have patterns for the right side. We can lay them out on the purchase brackets and cut them out. The pattern is clamped to our purchase bracket. The holes lined up, and now we'll scribe it. And now with the pattern scribed onto the purchase bracket, we'll go cut it out. Now that we have our bracket cut out, what we're going to do is round the edge a little bit so no one can get cut. Let's see how we did. That one slides in real nice. That one slides in real nice. I think we've got it. Let's measure. We're 2 3/16 from the outside of the frame. With this side fitting nicely, now all we got to do is do the other side. Before we do the brackets on the left side, we have to make sure the motor is level side to side. The frame currently measures 0.5 degrees, and the motor currently measures 0.6 degrees. It's 1/10 of a degree off. I think that's close enough for us to do the brackets. Now's the time to see if our patterns from the right side fit the left side. The rear one slides over the frame. The bolt doesn't go in. If I raise it up just a touch, the bolt slides in. There's a little bit of a gap at the bottom of our pattern here. If I put a piece of tape across there, I think we'll be all right. How about the front one? The front one, the notch is not wide enough for the pattern to slide down over the frame. So we can't slide the bolt in until we widen it up a little bit. We were able to modify the patterns that we used on the right side, on the left side with some modifications. And now the bolt slides in. And what we have to do now is clean these up and prepare for welding. I have the brackets cleaned up and ready for welding. First thing we'll do is tack them in place. One thing you should know, that I know, is these brackets are not straight up and down. And that's because the motor is at an angle. If you look at that gap, you can see that the motor is at an angle. And it is tilted 5 degrees to the back. So these are not straight up and down because they're flush with the mount. Other than that, I think we're ready to tack. I'm not a fantastic welder. I'm still learning. And this is not an easy weld because I'm going to thick to thin metal. So let's hope we don't blow through the frame. What I'm going to do is tack them in, take the motor out, and weld them in so we don't get the splatter on the motor. So here we go. Those tacks should be strong enough to hold the brackets in place. We'll pull the motor out and we'll weld it up. I've cut a piece of tubing the same length as the engine mount bushings, and I've put it in between the brackets to keep them from closing up when we weld it. And now we are ready to weld. Okay, here we go. Here's some welds that came out fairly decent. I won't show you my ugly welds. We have the transmission bolted to the transmission bracket. We have the right hand motor mount bolted to the new brackets. Let's see if this bolt slides in, and it does. Let's put a nut on it. We have all the weight sitting in the chassis. We were looking for 5 and 13/16, and that's what we have, 5 and 13/16. What does it measure to the ground? And it measures to the ground 24 1/4, and we're depending upon 1/4 inch of drop when we put the body and all the weight into the car. I think we accomplished what we wanted to do. We wanted this bolt to be 5 and 13/16 above the cross member we had here, and the motor itself, the center line, is 24 1/4 inches from the ground. When we put the body on, I'm sure that the chassis will lower by the 1/4 inch we need to get it to 24 inches. So I think we accomplished what we wanted to accomplish. If you enjoyed this video, there'll be more.